This video shows an isolated rat lung that is being ventilated with volume control ventilation at two different levels of PEEP. The key points to look for in this short video are the marked heterogeneity of expansion of the lung, the time required for recruitment of the lung, and the need for a sufficient PEEP level to maintain the lung recruited. Note that because there is no chest wall in this model, the lung collapses entirely at the end of expiration during no pressure, which is not the case in vivo. This image is of the lung just before ventilation, using a tidal volume of 7 milliliters per kilogram and a PEEP of 0. The dark regions are areas of collapsed or atelectatic lung. The lung inflates heterogeneously. At the bottom of the lung, inflation is homogeneous at the end of inspiration, whereas areas near the top remain collapsed. The PEEP level is increased to a pressure of 15 centimeters of water, and the collapsed lung is starting to inflate, a process called recruitment. The lungs are more homogeneously inflated with each breath. The areas of atelectasis are disappearing with each breath. At the end, the lungs are completely inflated, and the inflation is homogeneous. The PEEP level is now decreased to 0. The first inflation looks relatively homogeneous, with no major areas of atelectasis. On the second inflation, large areas of heterogeneity and atelectasis appear at the end of inspiration. With each breath, there is collapse of the lung and then re-expansion of some areas, but again, there are some areas that remain collapsed throughout the breath. We can see that it takes many ventilatory cycles for the lung to be recruited. In patients, the time is much longer than the few breaths shown here, and it can take hours, depending on the disease process and the pressures applied. To maintain recruitment, it is necessary to keep the PEEP level relatively high. As soon as PEEP is reduced to 0 by the second or third breath, areas of collapse appear, a process termed de-recruitment. Although the lungs of a patient receiving ventilation would differ from the rat lung shown here, the basic physiological changes would probably be quite similar.